Hi, I'm Lucas, and I want to show you a proof of concept of a tool that I made for type-safe SQL without using any ORM. I want to get your feedback and see if it's something that you would use and you want me to develop further. I want to start with the question, wouldn't it be great if you could write SQL query like that and just run some command and generate this chunk of code without writing a single line of code? It gives you a return type, a type for variables, and a function that you can execute to get a value. So everything is like type safe and you have full auto completion. So that's what I made and I want to show you how it works. But first, when you start a new project, a backend project, very often you ask yourself a question whether I should use no ORM and write your queries manually and define types for them, or maybe use some ORM, don't write queries, don't write types, but then in the end you still will end up probably writing queries manually because you can't just implement every single query using ORMs. So here's an example of a very simple query that is counting records using filter, and just to my knowledge it's not possible in ORMs. In this example I'm just using type ORM, so maybe it's possible in other ORMs, but anyway there are like more complex queries that are impossible to create using query builders or whatever the ORM is using. And what's the problem with this kind of code? First, you have to define those types manually. And then whenever you change something in database or you change your query, you have to remember about updating your types. And you might forget about that. Then you will just have an error in the runtime instead of on deployment. So that's why I made SQL code generator. And it's heavily inspired by GraphQL code generator, which is a great tool. I wouldn't start a new GraphQL project without it, so kudos to authors and thanks for great inspiration. This tool was written in Rust that I just learned for this project, and I also used SQL parser, a Rust library, without which it would be really hard to just implement parser. So let's write some code and see it in action. So here's an example project that I made to demonstrate how it works. For now, there is no npm package that you can download. So for now, I just copied the binary directly into the root of the project and I just linked it in the package.json scripts. So now, before we start writing some code, let's go to database, and we have here two tables and some data in each one. It's a Postgres database. So we try to fetch some records from here. Now let's see in the index file that we already established connection with database, and the first thing that you have to check is your config file. And if you use GraphQL code generator, it will look very familiar, but here's a quick explanation. First you have to define your dialect, so in this case it's Postgres, some connection options, schema file, so we'll talk about that in a moment, and the list of files to generate. In this case, I'm only generating one file, and here's a list of plugins that I will use with this file. And as the last thing, there is glob pattern for queries. For those queries, we'll generate types and functions to execute. So let's start with maybe running our application. I'm using yarn, but it doesn't really matter. And yarn SQL codegen and schema to download the schema from our database. And as you can see, it created a file, and here we have two queries, SQL queries. For each table, we have a list of fields, types, and some extra options. So now let's generate types for those tables. So I will just remove schema command and run it again. And now we also have types.ts file. Let's talk about that. So first thing is a list of scalars. So it's a mapping between SQL type and TypeScript type. Next we have two types, one for comments table and one for users table. We have some extra types and some SDK code. We'll talk about that in a moment. So let's create first query. I will put it in the queries directory. I will call it find all users SQL. So for this, it would be very simple. Select all from users. And I will run this command again. And let's see our file again with types. This time we have extra types beside tables, and we have find all users query result types. So you can see that it gave us all the columns and types for each one. We also have some SDK functions for this query. As you can see, the name is the same as the file name, but it's just camel cased. So now let's try to use that. Let's go to our entry file. I already prepared some code, so I'm importing getPG_SDK function from this file, and then I'm initializing that with the client connection. Now I can just execute SDK, find all users, and I'm awaiting that, and here I have users list. And as you can see, as I hover over it, I can see that it has all the type information. And here I'm just logging that, so I will save and see what it produces. Yeah, as you can see, it fetched a few records as you would expect. So now I will modify query a little bit, and it's important to note here that it could just watch all the query files, so it would just automatically rerun generation. But for now, I will just run it manually. So what I will do, I will just fetch ID and first name as first name. And I will generate types again. And now it will also rerun the application, and you can see that now it's only has ID and first name, but also types were updated. So if I do users and first record, it will just tell me that there are only 2 fields there. That's a quick demonstration. And it only works right now for very simple select queries, but I also tested that with update, inserts, and also with joins, and everything seems to work well. There's also a problem with joins. It comes about hydration. So in this example, all the comments for each user would end up as an array of records in the user object. That's great if you are using ORM, but it's computationally heavy. So I would rather not do that, but it's possible if you order to make it work. But the problem with that is that it will require a query rewrite. So basically, if you do some joins in your query and then use SQL code generator, it will produce totally different query. So that's a problem from debugging perspective, for example. And I wouldn't want to make debugging harder. Basically, what you wrote in the query file should be what is being executed, maybe with just small changes, but not influencing the overall shape of the query. So, I made more tests, and I thought, okay, could I maybe do it differently? And I come up with this query that to my knowledge, it's only possible in Postgres because it has JSON B type. Maybe there are other SQL databases that also have this type. I don't know. But as you can see, it's not pretty, but it works. So maybe if someone wants to do aggregation or like hydration, they could do this, and then you can have like comments table, comments field with nested records. And yeah, I think like most people that are for writing queries manually would agree with me that you don't really need hydration or aggregation to just work with your SQL. You might just keep the data structure flat, and that's it. And you just work with what you have. So that's all for this demonstration. I hope you liked it and I didn't waste your time. And if you have any question, comments, or maybe you would like to support this project, I'm open for cooperation. Here's my contact information. So feel free to contact me, and see you soon.